Hi everyone. Finally, the moment you've been waiting for, using the systematic treatment of equilibrium, and there's only 6 easy steps. The first one is you'll write down all your relevant chemical reactions, and sometimes those may be given to you. Then you'll write down a charge balance and a mass balance, and there may be more than one. You'll write down all of the K expressions for the chemical reactions that you wrote in step 1. So probably it'll be a KSP, always a KW. You may have a KA or a KB. And then in step 5, we kind of pause, we step back, we make sure that we do in fact have enough equations to solve the problem. So we have to make sure that the number of equations is greater than or equal to the number of unknowns, and then finally solve using algebra. So let's do an example, and this example will be a simple one because we don't really have to use the systematic treatment, but it might be a nice way to kind of get warmed up. So here's our example. Calculate the concentrations of all ions in a saturated solution of lead-2 chloride. I hope you're thinking what I'm thinking. A beaker of water, and then we have solid lead-2 chloride in this beaker, a saturated solution. Step 1, write down all your relevant chemical reactions. Well, I know we're going to have a KSP, lead-2 chloride, dissociates into lead-2 and 2 chlorides. And we have the KSP value, which is nice. Another relevant reaction is going to be the dissociation of water. This is always going to be a relevant reaction. KW, they didn't give it to us, but I'll give it to you on tests, is 1.0 times 10 to the negative 14. Step 2, write down a charge balance. Positives on one side, negatives on the other. The charge of an ion becomes its coefficient. So we have H plus and twice the lead ion concentration. I think those are all of our positives, equals OH and the chloride ion concentration. And now for the mass balance. Well, from the KSP, I would write the concentration of chloride is twice the concentration of lead. And then from the KW, I could also say that H is equal to OH. So we do, in fact, have 2 mass balances here. Step 4, write down the expressions for K for all of the reactions that we've written in step 1. So KSP is equal to the concentration of lead-2 times chloride squared, and KW is equal to H times OH. And step 5, I'm just going to put here, this is where we kind of make sure we have enough equations to solve everything. So first of all, how many unknowns do I have? 1, 2, 3, 4. 4 unknowns. And how many equations do I have? 1, 2, 3, 4, 5. 5 equations. So this is solvable. And I don't know where you want to begin, but I'm looking at this KSP and I'm looking at this mass balance, this relationship between chloride and lead-2. What if we put this expression for chloride and plug that in to the KSP? I think that would be helpful. KSP is going to be equal to the concentration of lead-2, and now for chloride, I'm going to write this. So it's twice the concentration of lead-2, the quantity squared, which would be lead times 4 lead squared, or 4 lead cubed. And solving for lead, Let's see, what would that be? I think I'm going to have to take the cube root and then take that KSP, 1.7 times 10 to the negative fifth, and divide by 4. And I got 0.0163 molar lead 2. And there's a couple of different ways we could get chloride, but this seems like a pretty easy way, just double the lead concentration. So chloride equals twice the lead ion concentration, and I'm getting 0.032 molar for chloride. And now the only other thing we have to do is solve for H and OH. Let me scroll up a bit. We've got this expression for Kw, and we see that H and OH are equal, so that should be pretty easy. Kw equals H plus squared, let's say. H plus equals the square root of Kw, which is 1.0 times 10 to the negative 7th molar, and that also equals the OH concentration. So that was just a very simple example using the systematic treatment of equilibrium. Hope you feel warmed up because the next one is going to be harder. Thanks for listening.